Hello, my name is Sushil Kumar and I will today explain how to use NS2. First of all, for using NS2, we need to install NS2, which we can do in Linux very easily just by typing sudo apt-get install NS2. Once you press enter after this, then it will ask you to install NS2. You have to just press enter, yes, and it will install. I have already installed this thing. After installing NS2, you have to install NAM. This NAM is a network animator, means it will be used to show the actual functioning of how the nodes are interacting and all things. NS2 is a network simulator. So now we will start our program. So I have made a program about handoff in Wi-Fi. So we will see what the program now. So this is the program. What the program says that it's a handoff. So for setting, it's a wireless environment. We are creating nodes, and here we are giving values to our variables. This specifies channel over here specifies which channel we are using, wired channel or wireless channel. Then propagation medium, what kind of propagation we are using. Here we are using two-ray ground propagation medium. Then for the wireless, the network interface card, we are using a wireless network interface card, that's a wireless physical. Then for the MAC, which protocol we are using in the MAC. Then here we are using 802.11, which is the standard for wireless LAN, that's why. And for the queue, which kind of queue we are using. Here we are using a queue which is of drop tail type, means that packets which are extra will be dropped from the tail of the queue, and it's a kind of priority queue. Then we are using link layer. The antenna, which kind of antenna we are using in our nodes. Here we are using omni antenna, means it will send the signals in all the directions equally. And then we have queue length. What is the maximum length of the queue of? Here we have set it to 50. Then how many number of nodes we are using. We are having 10 nodes. Then what kind of routing protocol we are using. We are using a dumb agent routing protocol. Why we are using dumb agent means because we are just showing handoff. We need not show how the actually routing and all those things happen. So that's why there we are using a dumb agent protocol. We will just take the packets and it will send to the other node. Generally in wireless scenario we use AODV, DSDV like protocol, and this X and Y we are setting 600, 400. So now we are setting the data rate. This data rate means at what speed our data will flow. We are setting it at 11 Mbps. This is our MAC 802.11. Then we are going for setting the variables. NS, set NS. NS this is just a name we have given. Here we give new simulator. Simulator means it's a kind of simulator object. New means using new we are creating object. Then we are setting a variable trace FD, and we are opening a file project1.tr. This file, and with w means we are giving it write permissions. We will write on that file. Then we are linking this simulator to this trace file by telling that ns trace all into trace fd. We are putting all the information about trace into this trace file using this handler, trace fd handler. Then after putting trace, we are using a NAM trace. Why we are using NAM trace means this trace will contain all the records by line, means in numerical manner. NAM trace will also keep it like that only, but using NAM trace the output is executed, so we need to keep a NAM trace. So we are opening a project one NAM.NAM with write permissions and NAM trace, and the handler is NAM trace, and we are assigning NAM trace handler the value of to get all the value of wireless communications happening, and we are setting NAM trace val x, val y. This is the area which it should cover. Then we are setting a topography of our network, which is using new topography object, and we are loading a flat grid topography. X and Y are the X and Y coordinates of length and breadth of our topography. Then we are creating a God object, and we are sending it a number of nodes which are there in our network. Why we create a God object means God object stores the information about all the nodes. It's a kind of global information. It stores information about all the nodes and all the configurations and everything on the network. This is used to find the shortest routing and all those things. It should not be told to any particular node. And then we are setting the channel. Here we are setting set chan1 channel new value of chan wave, where we declared value of channels chan wireless channel above. we are setting it. Then we are configuring our node. Node config means we are telling our configuring our node. Then we are setting ad hoc routing. Ad hoc routing, what kind of routing protocol we are using. Here we are set val rp dump agent that we are doing. Then we are the link layer type, val which we are set. Then we are using MAC type. Which MAC type? We are giving val MAC, which has been given on the top by MAC 800.2.11. And like that we are setting all the values, query, queue length, and antenna type, propagation type, physical media, topography instance, what kind of topography is there, agent tracing, router tracing, MAC tracing, movement tracing, channel, all these things we are assigning to the nodes. Then we are running a for loop for set I0 means from 0. Then here is our expression, test expression, I less than expression val nn. Nn means we have given here a node to be 10 over here. We have given it 10. Then we are running this loop for 10 times and incrementing one by one, and we are creating a node array. And in that node array, using this node which we have defined over here, we are creating nodes with the same configuration which we have done over here. And we are creating nodes, setting the random motion 0 means it will disable the random motion. We are setting its MAC. By get MAC it will get its MAC ID. And we are doing this, we are creating nodes, 10 nodes. Then for each 10 node we are setting the position, set x, y, z means in the xyz in the xyz here in the space, what is the x coordinate, y coordinate, z coordinate. We are specifying for all the 10 nodes, node 0, node 1 like array. We are set for all the 10 nodes. Then we are labeling, when node 0 label ap1 means we are labeling all the nodes. Ap1 means access point 1, and n1 means it's a node 1, mn1, mn2. Like this we are naming all the nodes in our network, in our wireless scenario. Then we are adding color, we are adding mark and color and shape. Here we are telling that first node should be green color, it should be of circle shape. We can use even triangle, square or any other shape. Then we are red circle, we are specifying colors and shapes to all the nodes. Then we are assigning access point address to the MAC using AP address 1. We are assigning MAC ID to our access point. Then similarly for our access points 2, we have set node 9 and node 0 as access points, and we are assigning address to that. Then we are telling that MAC should what kind of our access point should be active or passive, what kind of way it should behave. Active means it will continue sending the signals, beacon signals to the to the nodes, and passive means it will here active scanning means the node will continuously search for the what all it will send the probe request to what all are its nearby Wi-Fi access points. And passive means the node will not send anything. The access points generally sends a beacon signal after every 100 milliseconds, and using that beacon signal the node will change its access point that we are doing. Then we are using application traffic CBR. CBR means constant bitrate traffic. We are setting its packet size to be 1023 and its bitrate to be 256 kbps, and then that way we are creating a constant bitrate traffic. Then we are assigning, then for each node we are creating agents. We are creating a UDP agent. UDP means user datagram protocol. We are creating a UDP agent, and we are using attach agent. We are attaching that UDP agent to a particular node. Then using CBR, then we are attaching like this to all the nodes using a for loop. Then we are creating a null agent, because the UDP packet UDP agent will send the data, and there should be a agent to receive the data. It's a kind of when we use TCP, we have a TCP agent, and for the receiving end we have a TCP sync. Like that we are creating a null agent for receiving the data, and we are attaching it to the node that will receive the data. And using connect, we connect the UDP agent and the null agent. Like that we are doing for all the nodes. Then we are initially set the positions of the node using initial node position. Then we are NS at particular time. We are specifying the time, and at that time we are starting our constant bitrate traffic for node number 2. Like this we are starting for each node, specifying the time at which it should start. Then we are setting using set we are setting the destination at where that particular node should be. We are setting the particular destination using xyz coordinates of the node. Then we are setting a stop. We are calling stop is the function that has been defined by us. This is a function, and at the end we are setting puts. We are displaying the message that ns is exiting and ns halt. Stop function what we are doing in stop function means we are creating a global, we are using a global variable ns and trace fd, which have been defined on top. Here we have defined ns and trace fd. Since we are using it inside the global inside the function, it's outside, which is outside the function, that's why we are using global. Then ns plus trace means it will close the trace objects. Then it will stop taking values, and close trace fd will, it will close the handler. Then we are giving the command exec, which will execute the command nam is the command which is used to execute the nam file that we have created, project1.nam. We created on top the nam project1.nam. Here we have created project1.nam using open variable and with write function with nam trace and assigned all the nam trace value of wireless values to that file. Here we are sending the command to execute that thing, and exit 0, it will close the thing. Finally we are calling ns run, which will run the ns. This is the execution, this is the explanation of our code, and now we will see how our code executes. For executing a code, we type ns, then the name of the file, then we enter. See, initially the list has been created, antennas and all those things have been set. Then it's showing that initially no AP is in range, and handoff adapted when the node is moving from one place to another place. Now we will show the execution using the using this NAM. Now we will give the play option. This NAM has various options. This is fast backward, this is backward, this is pause, and this is play, this is play faster. Here we have step function, which how much steps it should take to load front frame. We can reduce it from 1 microsecond to 794.3 milliseconds. That is the step it will take. Here we have time function, which we can drag and put to any time, and we can see our value from there. Here we can drag it using this, and you see the value over here changes. And so now we'll start it from beginning. See, in the we are setting the nodes. Our node moved from one place to other because we have set it ns. We are set at 10.0. Now we see that our nodes have been set, and this circles that are showing beeping, that the circles are the transmission that we have set CBR. They are transmitting continuously, so that's what we can see. And here we are setting that at 10.0 our node will change the destination, so we will drag the pointer, we can and show exactly fast. See, 9 at point. See, now our node is changing since it's moving, that's why it's changed its position from here to here, and like that. And that time only a handoff was attempted, which was shown by our over here, that when the client 4, which is our this thing, it moved from the access point range of AP1 access point 1 to access point 2, then there was a handoff attempted, which was shown over here. Then we have movement at 35.0, so we will drag our pointer to 35.0. So now we have put it at 34. Now see, now we'll see that a client 5, as the client 5 is moving, since it moved from the access point area of the AP0 to AP9, again it showed that there is a handoff attempt from AP0 to AP9. Then we have a handoff attempt at 50.0, so we will drag our pointer to 50. Now we can see that our MN2 is moving from access point area of 0 to 1, so it shows handoff attempted from AP0 to AP9. Then at 52 we have a node moving from AP9 to AP0's access point area, which will be shown. See, as the node is moving from access point area of 3 to 1, it shows the access point handoff attempted from AP9 to AP0. This is how handoff occurs in a Wi-Fi, which can be shown easily using a NAM thing. So now we'll stop it and we can close it. Here we are seeing the trace file. Here this specifies the number of the which record is this particular file. This record is S means it's a type of the packet, which kind of packet it is. It's a send packet, receive packet, or D for drop packet. This specifies the time at which this packet has been recorded. This specifies the node from which this packet is being originating, and this specifies the type, which layer it is, which type of packet. It is a MAC packet, and this specifies how much delay it is taking, means how much delay it is considering. Since it's 0 means it doesn't consider any delay in the network. BCN, it's a type of the which type of packet it is. It's a BCN packet. 72 is the size of the packet. What is the size of this packet? 0 specifies the MAC address of the packet from which it is originating. FFF, this specifies the MAC address at which it is ending. And 9 FFF, this means it's a broadcast packet. 9 is since 9 is our access point, so this is a kind of broadcast packet. It is being sent from 9 and it is being received at 0. This is a trace file. So this is all how the we can execute a network simulation in NS2 using NAM. I hope you enjoyed the video. Thank you.